started. All right, let me know if there's any connection issues or something like that. All right, lots of junk on the lots of stuff on the board. We'll get to the outer. I just pulled up this problem I remembered here and wrote it up in the board. It's actually kind of out of 4.5, I think, in the text, but something like that. There's an equation that supposedly represents what your cost would be to hire a certain caterer for a banquet of some sort. Okay. And so my first question is, what's the slope in that equation? And what does it mean? And then the second question would be, what would be the y-intercept of that equation? And what would that mean? What's the y-intercept mean or stand for or something, you know? So the first thing you might notice is that it's kind of in this shape, right? But it's reversed order here, right? The mx plus b is switched. I'll make my mx plus b look a little better here. We got a real good looking plus sign. So this is really kind of like b plus mx. Not uncommon to see it that way. Kind of got the fixed amount plus the variable amount instead of the other way around. All right. I see everybody so brave, they're all muted. But so what number in that expression? Okay, based on n number of guests, right? How many guests? So which number up there is the slope in this equation? Well, it's
28 is the slope and the 450 is the B is the starting point.
Yeah, okay. So thank you. I was actually, whatever I was doing, I didn't quite hear the first, but the fact you said the 450 is a starting point. Well, 450 is a starting point, which is a one way to sort of say the y-intercept. I might look for something a little more specific to the problem for the meaning. The 28 is the slope. So what does the 28 mean in the context? 28 what per what? Now, what are the units of the slope? There's a question that comes up. You know, blah per blah, you know, miles per hour. Units are that kind of comparison of this quantity per that quantity, units of the slope. So 28 what per what? You had to answer some questions like that in, I think it was 4.5, or maybe it was 4.4 where you had to practice slope. You know, they gave you that multiple choice list. Is it, you know, yards per dollar or dollar per yard or that kind of thing, right? Okay, if 28's the slope, right? And we're charging based on the number of guests. Here's the other thing I tried to mention early. I mentioned early on when we were talking about slope, the rate, the units of that slope are really your y units over your x units, just like the calculation. So what's the y value, right? It's the cost, and the x value is the number of people. So the slope units are cost per person. Y over x, cost per person. That's what this means, $28 per person, okay? That's what your slope means. That's kind of the thinking you want to put yourself through. It's like, all right, there's the slope. What does it mean? This problem wants me to answer. And so you're going to hire this caterer. What's the starting value? 450. What does that mean? If nobody shows up, you still got to pay the caterer the flat rate, something like that, right? So not unusual for a contract situation like that. There's a flat rate starting point and then an additional amount per whatever, per item. All right, so there, that was just a get the juices flowing kind of thing, warm up thing. All right. So we're still dealing, I'll say abstractly, with how to write an equation for a linear situation. if we have the right information, can we come up with the equation that models that situation? We refer to the equation as the mathematical model. I hear that phrase. So the necessary information, we need to figure out what the slope is, we need a slope value, and we need a point to work from. All right. Eventually, yesterday I got to these two different forms that we can use depending on the information that we have, and a couple different techniques that we'll practice. I'll kind of just, let's say, I'm going to do problems two different ways, and you kind of get you can pick which way you want. All right. I might sort of do a poll. I've not actually used the mom polls before, but I mean the Zoom polls, but you could let you speak up. Which way do you like best, right? Anyway, you need a slope and you need a point. If you know a slope and you know the y-intercept, how do you know it's the y-intercept? I just answered somebody else's question about this online this morning. Y-intercept is when x, the other one, when x is 0. If you know the slope and you know the y-intercept value, the easiest way to write the equation is to just plug it into slope-intercept form. I've got the m and I've got the b. Whoops, Steve. There we go. Ta-da, and that's that. I say that so matter-of-factly. Hopefully that makes a lot of sense, and you'll remember that because it's the next situations that we really need to spend more time on. Okay. If you've got a slope and you recognize that that's the y-intercept, or if the problem is really nice and says b equals, well, there you go. But there's the y-intercept. Y-intercept is when the x value is 0. We're up here someplace, right? All right. Well, that's the nice situation. What if you know a slope, but you know a point that's not the y-intercept? Maybe I picked something I didn't do yesterday that doesn't matter anyway. And does that matter? Don't think so. So here's a slope value. In fact, I'm going to move this over here so that I can use those two spaces. I have a slope value, excuse me, and a particular point out in the middle of the situation. So, got to write that equation. Two techniques, two molds, you might say. This one is called point slope, but you always end up having to rearrange your answer and put it in slope intercept as the preferred final form. You'll see that in all the instructions. Put your final answer in slope intercept form. That means this one. But this one, you plug things right in and then it's just manipulate. Here's the m, the slope value, and the point that you know are the x1, y1 numbers in that formula. So make sure you get the x and the y correct. Right? I want the y value to start. Y minus 2, the minus comes with the formula, okay, equals, what, 2/3 x minus 9. Again, that minus sign comes with the formula, okay? So that is now an equation for that line. And I just need to now do the work to rearrange it to get it in the shape to finish. That kind of always requires us to distribute here. Hopefully you've got a fraction. If you have a fraction, hopefully it plays nicely with this number over here. I kind of guarantee that for right now. And then you're going to have to move whatever this number is over there eventually, right? So here I go, just distributing. 2/3 times both of these. Now that would be 2/3 times 9. I could get 18 divided by 3 and be the 6, or cancel the 3's first. I think it's 6, okay? That's supposed to be 3, right? And now to get just plain y, I'm going to add the 2 to both sides. And that's that technique. So somehow it looks so confusing, and it's kind of can kind of be intimidating. But if you're careful and just plug things in properly, then the work that you got to be careful about rearranging. Now, what if I want to do that problem using the other technique? And here's the one I called, I think this is kind of my own phrase. I mean, this is what we are doing, but solve for B. Find out what the intercept is. And the idea here is if I know the slope and I know an X and a Y that has to work with the slope to make the right equation with the right B. So I plug in the Y I know, and the slope I know. Where did it go? There it is, 2/3. And the X I know. I'm going to make it look like a fraction because it's there next to that fraction. And now the only unknown is the B value, thus the Y-intercept, which we need at the end there. This should turn into that. And again, now it's simplifying the expression. And so that's going to be that 6 again, right? 1, 3, 6 plus B. I'm solving for B, so I'm going to leave the B and I got to move the 6. Right? Slow down, Steve. -4 equals B. Oh, that was nice, but I'm not done. I still need the final version of the equation, right? Now I have to take what I know. Now I know the intercept and the slope, and now I have to plug it in to the form. So two totally equal, you might say, techniques that you can use. This particular shape is similar to equation shapes that you might run into in more complicated kinds of equations, like next term or two, if you were going on to math 65 or math 95. I bet a lot of you are thinking of going 96. That one more class I have to take, and then I'm done, or something like that. But a version of this kind of shape gets used there, and of course we start with that in linear equations. This you kind of wouldn't see again, but it works, right? This one works. So I'm just going to do this again a couple more times, all right? Here we go. I'm going to erase that. Yeah, let's pick some numbers that work pretty well. Here's my slope I know, -3/4 slope, and I'm going to go through the point 4, -7. Not the Y-intercept. Okay, I got to do one of these longer, slightly longer techniques. All right. So I'll start here this time, okay? So the Y value, this is always unfortunate. It's almost like we see this Y first, but the Y is always the second number here, right? So here I go, -7 equals -3/4 times the X value 4, and then I can figure out what the intercept B value must be. Simplifying to solve for the B. -3. Okay, this is just total coincidence. Add 3 to both sides, and I got -4 again, just like my last example. That's totally a coincidence of the numbers I made up. You see that? That's a -4 is my intercept again. And now I have to go back and take those two pieces that I know now that are important and put them in the final shape. Here's the slope I started with. I knew that all along. And don't forget your X. Minus the 4 was the intercept. All right. Solving for the B. Plug in the Y for Y, the X for X, and the X slope for M. Doing it this way. Right. Y here, oh, this is a good example. Y minus a -7, right? Y minus a -7, you can totally just write Y plus 7 if you want, right? But that minus sign that comes with the formula, can't lose that. Right? Or remember to minus and turn it into plus. And x, what did I have? X minus 4. All right. Oh, slope. I get myself thinking about the next step and I forget something. There we go. There's my slope number. Sorry. All right, simplify. I got to distribute that slope times those two pieces inside. I'm going to call this y plus 7 equals, right, negative 3/4 x, and minus a minus is going to be plus. The 4's canceled, so I just get plus 3. Right, that's what I just did. Negative 3/4 times the negative 4. The 4's canceled. I got negative plus 3. And again, then I have to move the 7, subtract the 7 from both sides. And they are the same again. Either way. All right, and what can I do? Let's do one more. I'm going to put the numbers up and ask you to choose one way or the other. Both ways, both if you like. Give you a couple minutes to try to get there yourself, okay? And let's say I've got a slope, negative 2/5, and I'm going to go through 10, negative 3. Okay, 10, negative 3. Pick one technique or another. And see if you can get there, get the equation. If you're feeling totally lost where to start, choose one or the other versions, and then think about where you are going to plug numbers in. You know, the n for the m, and then you put in the x and the y's in the right positions, and then that's simplifying from there. Either of these techniques would be messier. Notice I'm making x numbers that kind of play nicely with the denominator on my slope. That's otherwise they get fraction answers. We're practicing the technique, not so much messy numbers. I see a heads up. Does that mean you're done? Somebody done over there? Oh, maybe not. Okay. See the same 4 faces, you know. If I go over here, oh, you're all hiding anyway. That's okay. There's a start over there. Here's a start over here, and I did the minus minus right away. Made it plus 3. You don't have to, absolutely. Whichever method you chose, let's see, be sure it looks like that to start. She heads down still. Oh, well, that's fine. I know there's multiple steps, multiple parts. Can't do too many of these, I understand. On a test, put it that way. You know, you also seem to feel so comfortable plotting points, getting your graph, or eventually plotting points, getting, you know, graphing the lines. And then all of a sudden we're getting more complicated here at the end, right? It always happens, end of the chapter. How'd you do? Did you get there? There's both versions. Did come up with that same y-intercept of 1. All right. Jump in or shout out if you're having trouble. Well, okay, I'm going to leave that up there because the need for those techniques is not going to go away with our next level of complication. Okay. Okay, if I erase. Okay. I keep saying we need a point and a slope. If I don't know the slope, I know 2 points. I need a slope. Even more work. You got to calculate the slope yourself first. Okay? Calculate the slope first. That's what this is all about. I know 2 points. I usually like to at some point mention, if you're looking at a word problem, sometimes they'll tell this story about, oh, in year 3, Billy's income was $10,000, and in year 5, his income was up to $17,000. Write the equation. They're giving you X, Y pairs. In year 3, it was 10,000, and in year 5, it was 17. Now those are big numbers, but they just gave you X's and Y's. Okay. Just throwing that out there as a side idea, because you get these, where these numbers come from in a problem. They're trying to relate, this goes with that, this goes with that. Now you've got 2 points to use. Okay, I got 2 points. I need to calculate the slope. Here I go. Here you go, right? Change in y's on top, rise over run. I'll do 6 minus 1. I should get the y's. 5 minus 3 are the x's. 5 halves. Slope is 5 over 2. Okay, that was that. That's the extra work here. Find the slope first. Now, pick one or the other. Doesn't matter, but you gotta stick with the same one. One point or the other, and pick now which technique you want to use. I've got a slope. I have 2 choices for the point. I just got to pick one. Use one. It doesn't matter. About 1 equals 5 halves times. Steve made a fraction. No, it's not. Yeah, it is. I made a fraction problem. Oh well. Good thing we don't have to graph it, maybe. 1 equals 15 halves plus b. Unless you see something I did wrong there. I have to subtract the 15 halves. All right. Okay, I'm going to call this 2 halves minus 15 halves equals b. Maybe you can see that. Right, the 1 was 2 over 2. 2 halves minus 15 halves, and I get that b is negative 13 halves. Okay, the point of this example was finding the slope first and then using the technique. Right, just so happened I have to scratch off that example in my notes. But just happened to have to do a little adding or subtracting of fractions. And so final answer, right? Y equals the slope I calculated was 5 halves. and minus 13/2. This one I have to do just about the same thing probably with the fractions, right? I'll use the same point, just x minus 3. Yeah, I'm going to get that same 15/2 over there, aren't I? Going to go y minus 1 equals 5/2 x minus 15/2. My 2's start getting funny looking. And now if I add the 1, I'm going to add 2/2, right? And we do get to the same place. Thank you. I appreciate that feedback. Sorry. You okay there? Stop me if you need to. We'll do it again. One, 4, and 6, 2. Same process. Find your slope value. You do that? Oh, wait a minute. Boom. That was a minute. Never timed it, but I bet that song is about 1 minute long. This should be this easy. Let's see, 4 minus 2, 1 minus 6. I think I'm going to get a fraction again. Darn it. I have to double check these examples I have.
Can we have a minute to work through it before you start?
Say again?
Do you mind if we just have a moment to work through it before you start solving it?
Don't mind at all.
Thank you.
I know I was not trying to do the whole thing. I was trying to maybe give you a head start and then do little by little. But yeah, I'll wait longer. Four minus 2, 1 minus 6. I was hoping I did it wrong so I wouldn't get a fraction. You know, couldn't get a fraction. Time. Okay. Hopefully you're far enough ahead of me. I'm going to start plugging some things in. Same equation for both, right? I didn't rewrite it. Don't look yet. Not done. It was my, 4/1, common denominator 5. It's the same as 20/5. So ended up adding 25ths. Is that okay? No objections?
I think it would help if we had time to solve the problem, and then once you're going through and solving it, you're walking us through the steps that you're making. I think that would help at least me start to understand like the steps involved.
Uh-huh.
I hope that makes sense.
Hard to tell whether you're done or not, and I was hoping that well, I could at least write things down before, while you were farther ahead of me. So, but if you're at this point, if you're finished, I can't spend 10 minutes on the one problem, I guess. I feel like we have to continue moving at some point, at some pace here. I plugged in, I chose this first point. I've calculated my slope, right? -2/5. I used the slope and I chose the first point, just arbitrarily 1/4. So there's my y, slope, and that x, and I solve for the b. Well, 1 times that slope is just that slope number, so I added 2/5 to both sides. Now 4 I had to convert so I could add to the fraction. 20/5 was equal to 4, right? So 25ths plus 2/5, I got 22/5 was the b value. Plugging that b in with the slope, there's that equation there. On this version, again, after calculating the slope, right? Had to do that. There's that y value and there's that x value. Distributing over here, -2/5 x. Minus is plus 2/5. This -4 is still here, so I added 4 to both sides, and the same 25ths, right? I added 4 as 25ths on this side and got that 22/5. It's about now when I usually say, we're really kind of you're lucky if you have a situation or a problem where you are given the y-intercept and the slope. It's probably much more common to get some other point out in the middle of the problem, especially in like maybe a word problem, something like that. Yeah, I'd say half and half in word problems. And they might tell you fixed amount plus the variable amount. So that's not too unusual, but it's almost like a special case where you really know what the y-intercept is. So we use these one or the other. You use these techniques a lot for this coming up with equation process. And that doesn't go away for our next kind of problem. All right. And so basically, we're going to keep practicing this, even though it's going to be kind of in a different context. I want the equation of a line that's parallel to y = 3x + 1, but it goes through the point 4, 2. Definitely something you're going to see, parallel or similarly perpendicular. I know this equation for some line, +1, 3x, it's some line that looks about like that. But I want a line that goes through 4, 2. So, it's over here. I want the line that's parallel to the first one, but goes through some other point. Back to what do I need? I need the slope to use and a point to use. This kind of problem tells you a point And you have to know where to find the slope. What's the deal with parallel lines? They have the same slope. What slope then do I need to use? And find the slope, or whatever, find it or look for it or something like that. So that's the deal with these. Parallel and the perpendicular had a special relationship, but it'll be the same kind of process. You're given an equation and a point to use, and then you have to figure out what slope to use out of that initial equation. All right, so here's the deal. Here's one of those things. He says this, and it's important. Okay, I've figured out what slope I want. I have this point. Don't do anything with that original equation ever again. We're done with that. That's all we wanted to know was what was its slope, so I can use that slope. Don't try to somehow plug all this into that other equation. Okay. Now I'm doing exactly what we just did a minute ago. I think that was Elizabeth that was talking to me. I'll wait if you want to solve it yourself now. Okay. No fraction slope there, so I'm pretty sure you won't get a fraction answer this time. Come up with that equation now. It's the same process we were just practicing, and we'll do this whole parallel and perpendicular thing again, but go ahead and do with this one all on your own. But, it's a beautiful day yesterday, supposed to be for a couple more days. And I guess that was the green light to go out and light your burn piles in the valley. At least the air seemed to be moving in the evening. Kind of seemed to blow it out. Does make sense. People couldn't burn during the rain. If they're inclined to burn, they had to wait for nice weather. But anyway, yes, I get that smoke. That doesn't react well. If I'm really going to wait, then I'm going to need somebody to speak up and say, I have an equation. I have an answer. Okay? You tell me what you get. Probably some method here in Zoom, but it'd be good to, if I had a marker so you could click the button when you were ready. I have to research that. Anybody ready? Seems like, I think it was, yes, 4.5 homework. There's quite a few of those problems where you have to use one or the other of these techniques. Graph one, figure out from the graph the equation, right? If you're looking at a graph and they want you to write the equation, you should look to find the y-intercept and then calculate the slope from the graph. And you need the slope and an intercept value eventually. You're looking at the graph. How's it going? Okay, I guess I was way too fast before. Sorry. Just kidding. Nobody's playing around. What did you get for y-intercept? That's sort of the problem, isn't it? Well, you know, it's we've kind of used it up. I'm going to let you keep working on that. Anybody have a question right now? And if you're not quite done, maybe I'll leave that with you as homework. That is, let's show up tomorrow and hopefully we've got an answer. Okay. If you're are someone doing okay and you want to sort of continue, I'll just point out that again for perpendicular type problems like this, its general process is the same. If you're given an equation and you're supposed to write perpendicular line, you have to figure out what the slope of the perpendicular line to this one would be. And remember those two changes yesterday, opposite signs and reciprocal. So for a perpendicular, you'd have to figure out, come up with the perpendicular slope, use the point that you were given, then ignore the starting equation again. Don't use the starting equation. All right. Well, keep practicing. There will be problems like this that you're expected to do. So hopefully you get comfortable enough that it goes, I'll just have to say faster, okay? That you get good enough at it that you know what to do and it does, you can get them done a little quicker. Okay, well, we're done for today then. I'll leave that there. We'll come back and we'll start with that and see how you did and carry on with that. And we'll definitely talk about some of the application problems in this section where you basically have to interpret the word problem and then create the equation for the problem. Okay, well, enjoy some sun if you can. Have a good day and I'll see you tomorrow. Okay? All right.